Hi friends, today we're going to talk about translations, reflections, and dilations. Our learning target, I can dilate and reflect figures on the coordinate plane. I can find the distance between a point and its reflection. Our state standard, use representations of transformations such as reflections, translations, scale changes, and rotations to solve problems involving figures on a coordinate grid. So a translation just moves the shape or the point up or down and or left or right. So any combination of those. If it's moving right, we add to the x coordinate. If it's moving left, we subtract that number from the x coordinate. If it's moving up, we add that number to the y coordinate, and if it's moving down, we subtract that number from the y coordinate. So we can look here on the first one, it's moving right 3 because we're adding 3. This next one's moving left 3 because we're subtracting 3 from the x. This one's moving up 2 because we're adding 2 to the y, and down 2 because we're subtracting 2 from the y. So let's look here. We have this original triangle KLM. The points are at -3, -1, 0, 0, and 1, -4. They want us to move 1 unit left, which means we're going to subtract 1 from every x value, and 1 unit up, which means we're going to add 1 to every y value. So for each of these points, we'll subtract 1 from every x value. So subtract 1 from each of the x values, and then add 1 to each of the y values. So our final answer then, -3 take away 1 is -4. -1 plus 1 is 0. For L, 0 minus 1 is -1. 0 plus 1 is 1. And M, 1 minus 1 is 0. -4 plus 1 is -3. We call these points K prime, L prime, and M prime. That little apostrophe just means what happens after it's been moved or after it's been transformed. So K prime is my new point after it's been shifted left 1 and up 1. L prime is after it's been shifted left 1 and up 1. M prime is after it's been shifted left 1 and up 1. So get another one. This one again is going left 1, so we'll take 1 from each of the x values, and down 1, so we'll take 1 from each of the y values. So for all of these, we're taking 1 from each part of our point. So our new points then, this will be -4, -2, -3, 3, and 0, 1. If we were to graph these, our original one, XWV, X is at -3, -1, W is at -2, 4, and V is at 1, 2. So this is our original shape before it's been translated. Our new shape then, our new X is -4, -2. So that's our X prime. W prime is -3, 3. And V prime is 0, 1. So you can see our black shape, every point in our black shape has moved left 1 and down 1. So get another one. This one, again, left 1, so we'll take 1 from each of the x values, and up 7, so we'll add 7 to each of the y values. So each x value, we're taking 1. Each y value, we're adding 7. So our final answers then, x will be negative 5, 2, or x prime will be negative 5, 2. W prime will be negative 4, 5. V prime will be negative 3, 4. And U prime will be negative 2, 4. And if we graph these, we would see that each point of our original graph moves left 1 and up 7. Next is dilations. Think above a dilation like a pinch to zoom on a photo. So if you're looking at a picture on your phone and you zoom it in or zoom it out, it changes the size of the shape but keeps its proportions and orientation exactly the same. To perform a dilation on a coordinate grid, you need 2 pieces of information. The center of dilation, usually at the origin. All of ours are going to be at the origin. And the scale factor. So the scale factor is really just what we're multiplying x and y by. K is our scale factor. If k is bigger than 1, it gets bigger. If k is between 0 and 1, it gets smaller. If k equals 1, then it stays the same. And then we don't need to worry about this rotation yet. So let's look here. If we graph our original, A is negative 1, negative 2. B is 2, 2. C is 2, negative 2. So this is our original triangle before we do our dilation. And it says it wants us to do a dilation of 2. That means we're going to multiply everything by 2. So times 2. The x and the y values. So our new A prime then would be negative 2, negative 4. Our new B prime would be 4, 4. And our new C prime would be 4, negative 4. So let's look at that graph. Our new A prime, negative 2, negative 4 is down here. Our B prime, 4, 4. Is up here. And our C prime is 4, negative 4. So down here. So if you look at this, oh, I just realized I put my A in the wrong spot. My A prime, oh no, that's in the right spot, negative 2, negative 4, okay. So if I connect my points here, we can see that our triangle has gotten bigger by a factor of 2. So each of my lines has gotten bigger by 2, or each of my sides. All right, this next one, dilation of 0.5. So we're going to multiply everything by 0.5. All of my x's and all of my y's. So our new points then are going to be negative 0.5, negative 0.5 for t prime. S prime, 0 times 0.5 is still 0. 2 times 0.5 is 1. And our R prime, 1 times 0.5 is 0.5. 0 times 0.5 is 0. So let's graph this one quick just so you can see what it looks like if it's getting smaller. So our original T, our original S, and our original R. So this is my original triangle in blue here. And then we'll do our new triangle in green after it's been dilated by a factor of 0.5. So the first one, negative 0.5 will be right here. 0, 1 will be here for our S prime, and our R prime will be right here. So we can see that our triangle has gotten smaller by a factor of 0.5. So it's about half the size of our original triangle. So get one more, dilation of 2.5. So we're going to multiply everything by 2.5. And then our new coordinates, negative 1 times 2.5 is negative 2.5. 0 times 2.5 is 0. 2 times 2.5 is 5. 1 times 2.5 is 2.5. And then for u, negative 1 times 2.5 is negative 2.5. So those are our new points. If we graphed it, we would see that the new image has gotten bigger by a factor of 2.5. The last one we need to know then is a reflection. If something is being reflected about the x-axis, we change all of the y's to their opposite. If something is being reflected about the y-axis, we change all the x's to their opposite. So let's look here. We'll graph it. So E is at negative 4, negative 1. F is at negative 5, 3. And G is at negative 2, 4. So this is our original triangle. And they want us to reflect it across the x-axis, which means we change all the y's to the opposite. So if it's already negative, we make it positive. If it's positive, we make it negative. We're leaving the x's as is. So this becomes negative 4, positive 1 for E prime. F prime becomes negative 5, negative 3. Again, we're changing the y's. G prime becomes negative 2, negative 4. So let's look at what the new one looks like. Our new E, or our E prime, is going to go there. F prime, negative 5, negative 3 is going to go here. And G prime, negative 2, negative 4 is going to go here. So it's kind of like we took that triangle and flipped it upside down. Notice that in our green triangle, E was on the bottom, and our pink triangle, E is on the top, so it's switched. And then the distance between, since we only changed the y values here, we want to look at the distance between the y values, because the x values didn't change. So if we look from negative 1 to 1 is a distance of 2. From 3 to negative 3 is a distance of 6. And from 4 to negative 4 is a distance of 8. Let's look at another one here. This is reflecting across the y-axis, so we're changing the x's to their opposite. So our new G is going to be at negative 3, positive 3. Our new H is going to be at negative 3, positive 4. And our new I is going to be at negative 4, positive 4. So again, I just took all of my x's and changed them to their opposites. To find the distance between them then, we're just going to look at our x's. From positive 3 to negative 3 is 6. Distance is always positive. From 3 to negative 3, again, is 6. and from 4 to negative 4 is 8. So the new x values are 6 units apart, 6 units apart, and 8 units apart. Last one here, this one's reflecting across the x and y axis. So we're going to change both x and y to their opposites. So for E, our new point is going to be at positive 5, positive 1. F is going to be at positive 3, negative 3. And G is going to be at positive 2. There is no opposite of 0, or the opposite of 0 is 0. So our y value isn't going to change. Here for the distance between, since we changed both x and y, we need to find the distance between each of those. For our x's, from negative 5 to positive 5 is 10. And for our y's, from negative 1 to positive 1 is 2. For point F, from negative 3 to positive 3 is 6. Same thing with our y's, from positive 3 to negative 3 is 6. And then for G, from negative 2 to positive 2 is 4. And looking at our y values, from 0 to 0 is 0. To find the distance, by the way, just take the larger number minus the smaller number. So for instance, on point E, for my x values, my larger number is 5, my smaller number is negative 5. 5 minus negative 5 is 10. For our y values, the larger number is 1, the smaller number is negative 1. 1 minus negative 1 is 2. All right, friends, that's all I have for you today.